This video is about magnetic flux and magnetic flux density. One way to define magnetic flux is that it is a measurement of the total magnetic field that passes through an area. This is the formula that you find in the IB Physics data booklet to calculate magnetic flux, and here are the variables. The symbol for magnetic flux is the Greek capital letter phi. Let's explore this formula a bit further by examining a magnetic field that passes through a given area. The arrows represent magnetic field lines. Let's assume that the strength of the field is B and that the rectangular area that you see here is A. Theta that you see in the formula in addition to B and A is the angle between the direction of the magnetic field and the normal to the area. To represent this angle, let's take one of the magnetic field lines and draw the normal to the area where this field line intersects the area. Theta is the angle between these two lines. A special case is when the direction of the magnetic field is perpendicular to the area. In this case, theta is 0, so cosine theta is 1, hence the magnetic flux equals to B times A. On most questions in IB Physics exams, the magnetic field direction will be perpendicular to the area. Here are a few more key points about magnetic flux. The number of field lines is related to the magnetic flux through a given area. Logically, the more lines pass through an area, the larger the magnetic flux will be. Of course, this is only true if we compare lines that cut a given area at the same angle. The unit of magnetic flux is the Weber, and magnetic flux is a scalar quantity. Magnetic flux density, the second quantity that we discuss in this video, can simply be defined as magnetic flux per unit area. There are also more complex definitions for magnetic flux density, but for our purposes in IB Physics, we can just use this simplified definition. From the definition, it logically follows that the unit of magnetic flux density is Webers per meter squared. Magnetic flux density is a vector quantity, and it is numerically equivalent to the magnetic field strength. Since the Tesla is the unit of magnetic field strength, 1 Tesla is equal to 1 Weber per meter squared. This completes our discussion of magnetic flux and magnetic flux density. In the next video, we'll learn about Faraday's law and magnetic flux linkage.